this computer.
It says
Boom.
it's recording.
Booyah.
Yeah.
All right.
Well done, Foster. Well done.
Welcome,
right.
everybody, to the, I don't know, the 65th session of one of these recordings or whatever we're on.
Foster, you're in a new environment. You're not
I know,
in. Previously, it looked like you were in a utility closet.
Yes,
Closet.
utility closet is just right there. I just turned my desk around. I realized this would be a better view in the background, and now I'm staring at sheetrock.
Nice.
So I used to be able to look out that window, and now I'm staring at this sheetrock.
Well, if it's any consolation, all the people on the news they're in the same boat. You see them moving around, and so it's like totally whatever.
I really feel Christy, what did you do with your LinkedIn photo?
Oh, so it was distracting for other people, evidently, but it's still here. Hold on, where's Lincoln?
Yeah, I feel like that's like part of your image.
There's Lincoln.
Oh, nice. Yeah.
It's crazy how common that is on the news, by the way.
How common Honest Abe is?
Yeah, I swear, I'm going to say 30% of the people that are on the news have that Abe picture behind them.
No kidding. My husband ordered it, and it came framed, and so he put it here, and I didn't notice it for a while, and
Anyway.
noticed it via podcast. Right. Anyway.
We should get going. So tonight we have Jake Staub of Ripcord Engineering here to talk about all things HVAC, mechanical, IAQ, and etc. And Jake, in the bottom left, we have Molly Visk, who's an architect with a firm called Ferguson Shamamian out of New York City. I believe she promotes them as the world's largest custom residential architecture firm in the world, and the best.
Nice.
Of course.
Definitely the best.
And that's Christy Williamson in the bottom right, founder, chief executive officer, and chief operating officer also of Building Science Fight Club.
Also secretary, accountant.
All right, a real mom and pop operation.
HR.
We're like mom and mom.
Yeah.
All right, I like it. We're familiar with that.
So Molly and Christy, just so you know, I just met Jake a couple of minutes ago when I logged on. We don't know each other at all. I found him just through a different conference call I was on a couple of weeks ago, and went on his website. It looked super cool, and said, "Oh, that's good enough for me."
I'm not sure. I'm not sure I'd say it's super cool. I mean,
well,
it doesn't have any pictures. Oh yeah, for guys that don't like pictures, for Foster.
Exactly.
Yeah,
it was like that was unique. Let's put it that way.
I'll grant you that.
So anyway, I'm kind of hoping we can talk about mechanical engineering as it relates to construction and home design and building science and those sorts of things, because I would argue, ignoring vapor diffusion, it's arguably the most misunderstood concept in all of like the science of building. So I'm hoping in the next 55 minutes you can straighten out the entire architectural community.
Who, me?
Yeah.
Well, that's a lot of pressure. I'm not sure I'm up to that at 8 o'clock.
So let me start with some simple stuff. Like, why on earth did you jump from like, aerospace engineering or something similar to that into mechanical engineering and HVAC?
Well, the short answer is the lower barrier to entry. So, there's a guy called, now I try to remember his name. He's a builder up here. Jesper Cruz. Yeah, I don't know if you guys heard of him or not, but he makes the talk show circuit and presents at NESI. But, buildings have a pretty low barrier to entry as far as the qualifications concerned, design buildings or design systems for buildings. So when Sonia and I were getting out of the Navy, she came up here to Portland. I followed along later, but we're both Navy background with aerospace engineering backgrounds, and Sonia got more involved in the building side and kind of went to work for it was a mechanical engineering firm. They weren't doing, they're doing more industrial stuff. She was more interested in the commercial stuff and got kind of a start in that. And at the time I was building a passive house for us, right? And kind of learned how buildings work from, I don't know, nuts and bolts, drywall, like drywall, studs and
Yep.
drywall and
Yeah.
plumbing and all that stuff. Like,
Well,
so
it is important,
and then,
you know.
right. So, you know, basically we had to find something else to do because we came up to Portland, Maine. And I don't know if you guys are tuned in or not, but it like snows around here and, you know, there's a lot of ice. So there's not a lot of aerospace up here. Like, you know, down south of us in Connecticut, they do some Pratt and Whitney stuff and whatnot. But as far as like what we were doing, like there's none of that. So buildings, you know, it's like cars. If you got a car, you got a car problem, right? You got building, you got building problems. So it's like universal employment, no matter where you go, with a relatively low barrier to entry. And that's kind of how we got started in the whole thing.
I went to a college reunion once. I don't know, I guess it was probably my 5-year college reunion. It was so long ago that I don't remember which college reunion it was.
Right.
But I had a few friends who were mechanical engineer majors. And I, at the time, was working on a passive house as well. At my first passive house, I was working in New York City. And I was asking my friends who had majored in mechanical engineering how many classes they took as undergraduates on mechanical systems design for buildings. And they were like, 0, like none. What is that?
Yeah, zero.
Yeah, it's true. Yeah.
Well,
I think,
yeah,
Jake.
go ahead. I'll interject
think,
once you finish.
I have this theory that you bring an incredibly, you know, unique perspective to, you know, the design of HVAC systems and mechanical systems in general with houses, because, like, that wasn't your goal going through college or getting out of college or this or that. In other words, you kind of, you know, jumped in to a flowing stream with an entirely different background, but with, you know, plenty of analytics in that background. So my guess is, you know, you've applied that same analytical mind to this brand new field in an attempt to get caught up fast. And I would love to hear about that. Like you must have so many thoughts on like or questions in your own mind, like, wow, why do they do that? Why don't they do this? Why this seems silly, or that seems whatever, you know?
Yeah, it's kind of a blessing and a curse all at the same time. I mean, the advantage is, you know, we haven't been hanging around for people that have been doing the same thing for the last 25 or 30 years. So, you know, as a result of that, like, I'm just as prone to read stuff that's coming out of Europe as I am to read some, you know, piece that's coming out of Building Science Corporation and Sturbrick. Both of them are valid, right? They're doing stuff for different reasons. But the thing that would maybe bias people in the North America away from what the Europeans are doing, because they've done stuff the same way for a long time, doesn't really apply to us. The curse is, of course, that sometimes, you know, yeah, I mean, sometimes we just don't know enough about the way things are usually done. So, you know, that can generate problems as well.
Do you think we sort of romanticize sometimes how Europeans do things, especially with, I mean, I know we do it architecturally for very good reason. They have, I mean, it's beautiful what anyway, obviously we already know this from an architectural perspective, but from a mechanical systems design, or even an enclosure design perspective, Europe has a different climate. We have a different approach to water management in walls. We typically build with more moisture sensitive materials. That's on the enclosure side. On the mechanical systems side, are there really, I guess, of course, there's always something to be learned from how people do things in other places, but are the parallels a lot more tenuous between Europe and the US because our expectations for our interior environment is different and our climate is different, or is that not really true? And that, you know, we can be pretty good at designing this stuff, and there isn't a good European way, or good European ways are pretty easy to translate to the US and vice versa. Or I probably asked you like 16 questions. Sorry.
Well, yeah, but that keeps it. See, we have 55 minutes to burn up, so that can help. So where to begin? So what I would say about Europe is that they are far more systematic about what they do, it seems to me. And my observation is that their average intelligence level for the advanced system types that we're starting to see in America here, they're far further along in their knowledge base. So they've been dealing with high energy costs for a long time. So the sophistication and the elegance of what they're doing has been really wrung out over the past couple decades. And we're seeing those things migrate over here. And they're appropriate solutions. It's just the understanding at the engineering and the mechanical subcontractor levels is not comparable, I don't think.
So maybe a parallel is like window installation. I tell people, like, well, you don't have Germans installing your windows, like, who are normally making watches, or it's not the same. There's a different level of precision and craftsmanship that's more common there, and it's more of a cowboy approach here, which I love. I'm Texas, but
yeah, right. Well, it's not that I don't think that they're any smarter about what they're doing, but they are very diligent about what they do, and I don't know why that. I can't really say why that is. I don't really have a good answer for that. It could be part of it. Could be that they're dealing with construction types that are a lot more unforgiving in the way they go together. Like masonry is way more demanding than wood frame is. So that might be part of it. So I'm not exactly sure. From what I can see from the outside looking in, their governments are way more involved in supporting the advanced system types. It's not, here we have pretty good, like I can find reports on from DOE, NREL, and agencies like that examine the concepts that they use over there. But as far as pushing that concept forward from a whole, like a federal government level down into the lower lying levels, I just don't see the same drivers that exist in Europe.
Well, can I ask though, it seems to me there's this major split though between like residential and commercial.
Yeah.
In other words, you build a commercial building in Europe, any place, and you build a commercial building in the United States, you're going to have ductwork. I'm pretty sure. Whereas residential, like ductwork's really rare in Europe. At least it has been forever. Whereas in the United States, like it's really rare not to have ductwork. So like there's these two different skill sets with our workers, and just two different like histories of engineers designing stuff, and on and on and on.
Yeah, the Europeans are far more interested in water-based systems. Here, well, like Molly, is in the best residential design firm in the world. For stuff like that, it amazes me. Like my parents, like I grew up in a 1950s ranch in Chicagoland, right? With a shitty air-based system with ductwork, in the basement, and then terminals in the floor. And it amazes me that, these high-end, very expensive homes, some people come in and that's what they want. It's like, man, like you want what my parents have in that garbage 1950 ranch in Chicagoland? Yep, that's what they want. It's like, why? Like, why do that to yourself?
Well, we try to steer them away from making those choices.
Yeah.
I think more and more our clients are going to radiant heat systems, especially in colder climates, with maybe secondary air support, but the primary source of heat is going more towards radiant floors and water systems. And it's more comfortable for human like it is a more comfortable experience. And I think owners are slowly coming to terms with that.
Yeah.
The heat's the easy part. It's the cooling that screws you up.
Yeah.
Yeah.
You gotta move there very slowly. You don't want to hear it. You don't want to feel it.
Okay. Well, so Christine, she mentioned, and I think you too did foster the water side of the whole thing. And as it turns out, like aerospace engineering is hard. but, you know, HVAC engineering has its own hardness too. And it's vapor management, it's water management. So, you know, that whole phase change of water, like that's I think most people, to be honest with you, most HVAC designs, especially at the residential level, a lot of that gets ignored. At least around here for the cooling side. Now down in Texas, different matter. Like down there, like you're gonna have to pay a lot more attention to it than we would up here in the Northeast. But even so, like, you know, loads calculations where they're just considering the sensible side of the loading and not the latent side of the loading. Like, do you see that all? Like, it's not easy to understand the latent side of the problem, and it's not easy really to design around it. And so as a consequence, I think that a lot of times gets brushed aside, which is not good when you have, you know, these high performance building envelopes where you end up shifting the balance point of the building from what would typically be 65 degrees, you know, where you're at the break point between heating and cooling, and the envelopes are shifting that down into like the 40s. You end up doing a lot more cooling than you otherwise would in places like the Northeast. And to not manage that latent side of the load problem, we're seeing a lot of science experiments out there with that, I think.
Well, I would love it if you talked about that a little more, because I think I think for like Christy and I, and of course Molly, like that's an obvious statement. But I think even for most practitioners north of maybe, you know, draw a line through the middle of Texas and Florida, like I don't think they're paying enough attention to that. Like it's a common recommendation for me today to tell, you know, architects, contractors, who's ever building a house, and I'm not talking about commercial, a house, like, hey, just put a dehumidifier in your attic. I'm just telling you now, like, just do it. And now that's just like the most basic way to deal with it. But it seems to me that our enclosures have passed our average knowledge. Christy, you notice the same thing relatively?
Yeah, and I think also, like, if we take a step back from this and ask, what is it that we want the mechanical system to do? So we want, I mean, the big picture thing is we want a particular set of interior conditions that may or may not be different from exterior conditions. And that gets harder the bigger the difference is, or the more particular we are about what those conditions are. And what do we want, like, within that? Okay, so we want to create a certain set of interior conditions. We want to control temperature. We want to control humidity, because that matters for comfort and also health and indoor air quality and material durability. So temperature, humidity, and we want to be able to breathe fresh air. So we want to make sure that it's not stuffy. We're dealing with pollutants in our space. We want fresh air. And I think that what we see oftentimes is that, so previously in the US, we would just, and I'm not a mechanical systems designer, so maybe I shift that part of the conversation to our guest. But in general, we have created enclosure conditions where these three things are out of whack with each other. That we can't. It's helpful to be able to control them independently, and not have sort of a blunt instrument to do this. Have one system that controls, that's sort of intending to control all of these things at the same time. So maybe our temperature is right, but our humidity is too high, or too low, or our humidity is okay, but now we've overcooled the space to get that, and now it's it's uncomfortably cold in our space. Or we're great with energy, but we don't have enough fresh air to breathe. So I think what we're doing is we ask a lot of our mechanical systems designers, because we're really asking to do three very different things, and we don't want to give up a lot of space to do it, and we don't want to pay a lot of money.
Yeah. Well, that money problem, there's your problem. Yeah. So, the firm over time, so coming, back to Foster's original observation that, you guys are coming from a totally different skill set. Yeah. So, we are. And so that opens the evolution of our firm. It's happened pretty rapidly where we started, at the beginning of this whole thing. Well, we saw, maybe energy is the most important part. And we quickly found out that it doesn't matter, like Christine or Molly or Foster, whoever's coming in the door, they'll say that at the start. And that ain't true. Like energy, that's not, you can't sell, like if I go in and I try and sell a widget, it doesn't matter what the widget is. If I try and sell that widget and it doesn't have a payback period, it's not going in the job. I don't care. I've spent enough time trying to sell widgets that are better for the environment because they save energy and it doesn't pay the bills. That's what we found out. So over time, we've evolved to, we went from energy, so we kind of scraped away at that a little bit. And we kind of went for like the health part, like ventilation air a little bit. But really what we're doing now is we're developing comfortable environments. People seem to respond to that a little bit more intuitively. I can sell, for high-end stuff. And I'm sorry if I'm being parochial with the sell thing. It's just a euphemism for what we do. We have to convince people that what it is we're trying to, like, Christine is making a good point for all these things. And when it comes down to the line, it's a line item. So normally what happens is this. The client comes in, and like Christine is saying, they're sensitive to the interior environment. They don't want to breathe a lot of pollutants. They want to manage the humidity so their maple floors don't expand when the humidity goes up and all these things, right? But when that budget comes, that first cost estimate comes out from that contractor, that GC, it's typically got a single line for mechanical and plumbing. They don't tell you how much the ventilation costs, and you all know, it seems like you all intuitively know that you actually eat more air every day than anything else. Like, go ahead and try it. Hold your breath. You got to breathe, right? Like, it's not a matter of, well, I'm going to go without a glass of water for an afternoon. You can't, most people can't hold their breath for maybe 2 minutes. So you're eating a lot of air, but in this country, as far as ventilation is concerned, that's normally what like leaks through the walls. That's most people's conceptualization of it. So when you're talking to,
in fact, some people think that's healthy. They're like,
oh,
we want more leakage through the walls.
Yeah, they're like, why would I bother building a tight envelope? Like, so what the code tells me, like, who cares? And that's what I'm, going back to the energy part. It's like, the reason why you're building that tight envelope is because dollar for dollar, that's the best way you can save, yourself money on the energy end of it, but it's creating this ventilation problem. So, I think the industry is flipped. It's really flipped. It's really the wrong way. It used to be, up here, it's different down in the South, but up here, if you didn't have heat, you'd die, right? Like back in the old days in the Northeast, people would die in the winter because it was too cold. So you got heating first, and then came along the ventilation part. And up here, that just meant opening your windows. And then at some point in the 50s, they got mainstream, they mainlined air conditioning into the whole scenario. But that's kind of backwards for these high performance buildings. First and foremost, you need some air to breathe. And it's not going to come the old way, like from leaks under the door, through the windows, or something like that. So the balanced ventilation actually like, we actually do a lot of work on I won't use the foul language. We unscrew a lot of ventilation problems. And it normally has to do with people putting fireplaces in, and then they got these giant range hoods, but they got no makeup air, or they've built this tight building. They got some fairly good heating and air conditioning equipment in there, but they got no balanced ventilation. They're just trying to run bath fans with no makeup air again. Our opinion, like a lot of the residential projects, just simply don't have money for the engineering. But our position is that the more sophisticated these buildings get, the better the design's got to get. It's like, all these things that the building was relying upon, just to do things like balance the airflow by leaks in the walls, those aren't viable strategies anymore.
Well, Jake, can I ask a related question? Yeah, for sure, all of our systems are more complicated, et cetera. But it also seems to me that our entire workforce and design force has not yet caught up with like what they need to with regard to understanding the physical environment, and specifically air pressures. Imagine if everybody in the design community and the installation of HVAC or installation of windows, et cetera, kind of had an intuitive understanding of what 5 Pascal pressure difference would do over, a half a day or a season. All of a sudden, a lot of what we currently perceive as problems might go away. So part of me views one of our current problems as just understanding of the physics of what's going on. And, maybe 5 or 10 or 20 years from now, we'll be over that and things will be easier.
I think my personal opinion on it is people make enough mistakes that they'll gain an intuitive understanding about it. But making mistakes is a painful way to go through life. So, I mean, that's why I read a lot of stuff coming out of Europe. Like, those people, they've been doing it for a while. It's not that they, like I said in the beginning, it's not that they know so much more about what they're doing than we do, or that they're so much smarter than we are at what they're doing. No, really, they've just made more mistakes, and they're more deliberate about describing what it is they're doing. Now, I will say that, if you read some of the technical manuals coming out of Europe on HVAC equipment, it challenged me for a while to figure out what it is they were saying. That's the level of understanding they have about what it is that's going on in your building, how these systems interact with all these high performance envelope components, and what you got to do if you're going to try radiant cooling, how you're going to manage your latent loads, dew point stuff, and how you're going to squeeze every last dollar out of that air system or that water system you're putting in. Here's an observation I have. How is it we are in America, the richest nation on earth, yet we cannot install the same systems in our buildings, and we cannot take 6 weeks off in the summer? How does that compute? And they don't have, the proposition is they don't have the resources to execute this stuff, yet they are executing it on a wide scale, but we cannot. That just seems.
I think there's tons and tons. This I think is a fascinating discussion, and I don't know all the answers. I'm not pretending to, but because it's so much. It's part of so many other things. Building is more expensive there. It is a lot less expensive here, and there's a system set up in this country that supports that. And home ownership and mortgages and deducting your interest from your income taxes. There's all kinds of things that contribute to the building industry in different ways. And I think those things probably affect initial upfront capital costs in buildings and improvements, and the cost of building new versus the cost of retrofitting, and how long people expect to live in a building or care for it, and how quickly companies and corporate headquarters exist, right? Somebody was presenting on this a while back. Foster, I think you were at this presentation where it was they were saying that the average corporate lifespan is 16 years. So that's, if you're trying to plan for your company's future, how much maybe you're not being rewarded for building forever. And there's certainly a culture in different places that's a lot more, when we build forever type of thing. But in America, it's fail quickly. I was always mystified. This is an example that doesn't have to do with HVAC, but roofing. So TPO roofs, which is the most common roof on, warehouses like Targets, Walmarts, whatever. It's flat roof, plastic, single ply membrane roof. And it is substantially less expensive than, well, not substantially, but noticeably less expensive than the old school hot asphalt systems. But those hot asphalt systems last like way longer, and some of the European systems like the Kemper roofs, whatever, way longer. And the upcharge for some of these other roofing systems is like, Foster, what do you think? Like 30, 40, 50%? But
I don't think it's that much. Yeah.
They last more than twice as long. So
Yeah.
if you're a company like Walmart and you have like tons and tons of buildings, and you're in charge of maintaining them, why doesn't every Walmart have a Kemper roof on it? And my answer to this is because it's easier for Walmart or whoever to budget, okay, in 10 years, I'm gonna have to replace my roof, and I know what that cost is, and I can put it in my budget for maintenance, than it is to spend I can do more with that 30% extra dollars right now. I can invest that into selling a new widget or paying back my shareholders or whatever, like buying a yacht, whatever.
It's tax laws and depreciation.
And I feel like I feel like I've now steered the conversation further away from this, but it's, I think that might be a big contributor to why we see some of the systems that feel more temporary in North America.
Oh yeah. Well, I will say one buzzword we've had success with is to label the quality systems as heirloom type systems. So when we go into these
Heirloom,
heirloom, kind of
I
like
got to write that down. I never used that
heirloom,
before.
like
I
a
like
Philippe,
that.
like a Philippe Petit watch. Something you're going to pass on to your son. You guys have seen the ads. You read the magazines. Right. So so this dude named Robert Bean, he's big into radiant heating and cooling, right? And he's got this website called healthyheating.com. You guys should check it out. Like Foster, like it.
I know Robert Bean, but I didn't know he had a website.
Yeah, healthyheating.com. And it looks as like kind of guerrilla as our website. Like there's not, there's no real good way to navigate or anything like that.
Yeah.
Really
I've used his calculations in the past, by the way.
Okay. But so one point he does make in that mess of a website he's got is that we suck, like the HVAC industry sucks at marketing. So, where I go for marketing inspiration is like I go to luxury watches, or I'll look at luxury cars and all these different, and we're talking specifically here about luxury housing projects. Like, people don't retain the services of an engineering firm to do normal, run-of-the-mill stuff. So this tactic's probably not going to work. It's not going to work on somebody who's looking for the bottom of the cost scale system. But if you're interested in pushing the conversation towards more durable stuff in North America, heirloom seems to gain a lot of traction in the conversation.
I love it.
I know. I totally gonna steal that. Make it mine.
Yeah,
I like that. Well, Jake, let me ask you about something else. It's not entirely unrelated, but I don't recall any projects I've ever worked on where, like, early on in the development process, like either the homeowner or the designer or anybody on the design team is like, and let's just push that HVAC design to the forefront. Like it's, like it's always just like design, like, oh, wait a minute. What about HVAC? Hey, Mr. Engineer, get over here. Molly?
Right.
We have a joke in our office. We can design a 20, 40,000 square foot house. You will fight for inches for every duct always.
Yeah, I'm not sure why that occurs. But...
I don't either.
Okay,
it happens on every project.
I know. So, so like around 2017, we can talk a little bit more later about the disaster that this project actually turned out to be. But back in 2017, we had this job, you know, it was typical floor to ceiling windows, pointed east, you know, high solar heat gain type stuff as usual. And I was stuck like looking at another, we're going to squeeze this ducted mini split air handler up above a closet, you know, like 4 of them on this one floor. And you're going to try and duct this thing all throughout the building. I was like, you know, this is bullshit. There's got to be a better way than this. Like, and so I thought, well, you know, we got these radiant heated floors. Like, why aren't people doing radiant cooling? And that sent us down this rabbit hole of, you know, Mr. Bean and healthy heating. And now, you know, for the stuff Molly's talking about, like we've come to, like the first thing we do is try and push forward the idea of radiant heated floors. And then once they're set, I mean, most luxury clients want it. They're like, we want radiant floors because our Tootsie's got to be warm in the middle of winter, right? Everybody wants that. Only they don't understand that the floor is limited to like 82 degrees if you got wood floors, but that's another point entirely. So your Tootsies really don't get warm. They just don't get as cold as they otherwise would, but whatever. You might get fired if you like get into an argument with a rich client over all that. But suffice it to say, all these spatial constraints that are placed upon us, like we just decided, you know what, we're going to try and do this radiant cooling thing. And as it turns out, like totally legitimate. Like we don't do, radiant ceiling has more capacity, more cooling capacity than radiant floor does, because the radiant floor cooling temperature, the surface temperature, is limited to 67 degrees for thermal comfort reasons. But you can do radiant cooling off a floor as well as radiant heating. And when you read the European air to water heat pump manuals, they specifically harp on this point in order to make the mechanical systems more affordable.
Well, I need to be convinced.
Okay.
Because I'm the guy who's always like radiant.
You do? I'm sold already.
You're sold?
Well, because
total heirloom customer.
You said, yeah, I'm an heirloom customer. What can I say? I'll buy that. Oh, I'll buy that when I buy my Patek, you know?
Right. Fully petite, yeah.
Whatever,
how you say.
But just to add to that in terms of thermal comfort, one of the things I was sort of surprised to learn, I'm Canadian originally, but after college, I took a job in San Antonio and quickly forgot what cold felt like. Then I moved back up to Boston and rediscovered cold. And what I found, which was kind of interesting, when I rented an apartment that was sort of reclaimed, or I rented a room in a house and whatever, but the room I rented was reclaimed off of a porch, and it had never been insulated on the bottom of the porch. So the floor was freezing. I mean, it was so cold, and the thermostat heat was included in the rent. And so the tenants would like jack up the thermostat during the winter. So the air temperature would be like 85 degrees in my room, but the floors were cold, like really cold. And so it was very uncomfortable. And later
that's the technical term for that is radiant asymmetry.
I did not know the asymmetry part, but I learned about how comfort is not, the thermostat is kind of a blunt instrument, and air temperature isn't the only way that we experience comfort. We're very, very much affected by the surface temperatures of what's around us.
Let me interrupt you for 1 second. So what Christine is referring to is operative temperature. Operative temperature is made up of 2 primary components. One is dry bulb temperature of the air. The second is the mean radiant temperature of the room. If you cannot control the mean radiant temperature of the room, the operative temperature is also not controlled, and therefore the human being, it will not be comfortable. Go back. I'll end my segue. And
I'm selling Foster on the heirloom system for you, and I'm going to need you to take over again when I reach my technical limit. So,
all right.
So we want, if you're building a more high performance enclosure, which is to say that you're controlling air better, the enclosure is more airtight, and you're insulating it more, and you're using better glass, so you're doing a better job of controlling the surface temperature,
which is mean radiant temperature.
Radiant temperature.
Yeah.
So we're doing better at controlling the surfaces and the mean radiant temperature. So therefore, would I be all that concerned that the temperature of my floors is limited to 82? I'm going to be so comfortable and toasty there anyway. I'm not going to need the same range that I do in my thermostat, where you see people set their thermostats down to like 60 degrees, like in
yes.
some places, but they're not really getting 60. Like,
So here's my
talk about that.
Here's
yeah,
my.
So that. Oh, go ahead. Sorry, Foster.
Can I voice my issue? I don't have any doubt that the technology works and everything Christy said is spot on, but I just don't trust homeowners to operate the system without overloading it. What do you call it? You know, I just think the thing's going to rain inside the house, basically.
Yes, the rain.
In other words, like you have to control the humidity so well.
But Foster, you have to control the humidity no matter what.
Anyway, just have a separate dehumidifier.
I do, but I don't have to worry about like soaking, you know, my wall.
Yeah, you just need to worry about growing mold, right?
Yeah, but that's a slow process. That's like cancer versus like a heart attack, you know?
Right. Yeah, so I mean, you got a point there, Foster. What I would say to that is 100% of the buildings that don't have relative humidity control, you know, that have mold problems don't have radiant surfaces to blame.
Yeah.
You know, it's not like that. Here's the thing, like going back to my earlier point, the reason why you have these mold type problems is people aren't managing the latent load. If I put a radiant cooling surface in your house, you better believe I'm going to be managing the latent load.
Right.
Like,
Well,
I will know all about that.
Yeah, I don't have any doubt that like the system upon the day it's designed is ultra,
how resilient?
no doubt.
Yeah.
But like, let's have one graduation party and then talk. Like,
I don't know, Buster, it sounds so simple to me. This button does heat, this button does cold, this button does humidity.
Right. So
done.
imagine
That's so easy.
Yeah, but like, so it's summer, it's a hot summer day, like it's hot as blazes here in Connecticut today and humid and this and that. So let's imagine this was party night, you know, and I got 50 people coming over and the doors are opening constantly and, you know, all sorts of crap's going on. Like, and the only way I'm getting my cooling is from radiant cooling.
Yeah.
I have this tremendous fear. Like this happens all the time where like, even in our regular systems, we get, you know, water dripping out of our grills because like the wife smokes and she only has to leave the door open.
Yes, to leave the door open. We have plenty of those people. And the truth of the matter is, if you abuse your system, it doesn't matter what you put in there; it's going to drip. Like the thing with a radiant cooling system is, if I do it right, I can sense what's going on in your home, and I can raise the surface temperature to respond. So it will bring the temperature of the surface back up.
Now we're talking.
So that it doesn't condense, you know. But
then I start sweating. Then it's dripping off of me.
Yeah, but you know, if you're.
I don't think it's fair to design to an extreme condition, though. You can't expect your system to be perfect in a load that is 6 times greater than what it's supposed to be.
But in high-end residential, that happens all the time.
That's why you have multiple systems.
Yeah.
That communicate to each other. I think that's the biggest thing that we recommend, and the engineers that we work with recommend, is you have to have a smart control system that removes a lot of the human error from it. Because that's the problem. You don't want a client going up to
AI, I'm going to hang up.
No, I'm not going there.
Come on, you don't want to hook up to Bezos' Amazon Web Service?
No. But I'm saying, if you take a lot of the human element out of it and you set the home to respond to conditions and it can sense, that's another thing. As architects, we're so guilty. We move the sensors to the place that you can't see them, but then it's by a window or it's by the door. So you have to listen to the engineer when they place the sensor in the correct spot of the room.
The controls are the #1 cause of failure with mechanical systems.
No, exactly. That's why you take them away from humans.
No.
You put them away.
How many times have you been in a commercial building where like it's freezing in the space or it's
that's not the kind of system I'm talking about.
Of course not, because it's not working.
No.
So, what you're talking about, Foster, is zoning. And so here's the trend on the high-end luxury residential segment is like they want to zone the shit out of buildings. Like they want control in their yoga thing, and they want control in their dining room, and they want control for each of the guest bedrooms, and so on and so forth. Like,
Well,
I
Christy and
will
I
tell
have
you,
a friend whose expression is, if there's not a thermostat in every room, you're not even in the game.
yeah. And so if you're gonna do stuff like that, if you're trying to use air systems to do that, you're making a big mistake. Like a big mistake. It ain't gonna work.
Okay, so my understanding really is that the only way to really do that is to have separate, discrete systems that do different things. So just like I was saying before, something that controls temperature, something that controls humidity, something that controls
Fresh air.
that fresh air, ventilation, and then you precondition that fresh air so that you dehumidify it. Maybe you need to warm it, depending on where you are. Maybe you need to warm it up before you bring it inside. In addition to that, so you separate those out so that you have the maximum ability to control stuff. You can also handle extremes better because you can idle your building. You don't care about temperature that much if you're not in the building. You take out human comfort, take out ventilation, because you've got a 17,000 square foot vacation home in the Hamptons and you're only there 6 months out of the year. Or 2 months out of the year, then the rest of the time you keep it at low set points, but you make sure the humidity doesn't go nuts, and that's it. But you have to control them separately.
Yeah.
Yes.
Yeah, I'll go. The separate control stuff. Yeah, we're big believers in that. We get some, I'll call them affluent clients who build these extravagant homes, and then they want to reduce the set point in the winter. It's like, what the hell are you talking about? You want to save money now? Like, if you do that, if you do that, the only thing I'd say to you is, if you depress that dry bulb temperature low enough, we're not going to be able to make it dry enough to keep the relative humidity low enough. You know what I'm saying? Like, you depress the temperature in the space, the relative humidity goes up, not down.
I just want to go on record as saying there's actually a psychrometric chart on my other screen.
I was just going to say, this makes me think of college with the sling that you did in the experiment.
The horsehair, yeah.
I forgot about that. But you actually look at that, Foster?
I still own a sling slide closet. I just used one like 10 days ago. That's my go-to tool.
Yeah. So warm and, the old euphemism, warm and dry, like that is true, warm and dry. So you keep it warm and you keep it drier. You don't have to work so hard on dehumidifying, So there are limits to, like, this depression of set point thing, and so on and so forth. But yes, independent control of each thing, and by independent control of each thing, what I mean is independent control of the sensible side and independent control of the latent side of the heating and cooling problem. Typically, when you're talking to a more residential HVAC designer, is they will not have a full grasp of controlling sensible and latent loads independently as part of the total heating and cooling solution. They will typically talk as one thing, maintaining a set point on the wall, and that's adequate. That's the old way, and it's adequate for old technology buildings. This new technology stuff, we're seeing more of a requirement for latent control, but because people can't really sense it on the wall, and the equipment, if you're going to try and do that, usually requires separate equipment, which requires separate budget. Like, people often don't go down that road. But
so how does that have to do with okay, so now bring in zoning. So
zoning, whereas so here's another, like, weird thing, right? So the affluence normally brings along a better building envelope. So you get
better windows.
Yeah, God, they'll strap out. We're gonna make an R50 or an R60 wall. It's like, all right, yeah, right. And then we're gonna put in like a R10 window and all this shit. And then okay, well, what do you want to do for temperature controlling? Oh, we want temperature control everywhere. It's like, listen, the whole point of what you're doing is to make one giant zone. Get it? But they don't get it. They want temperature control everywhere. And then what ends up?
That actually causes a lot of problems with people who are clients who are highly sensitive to that. Then they walk from one room to another and they're like, why do I feel so comfortable in here and not in here? And then they fiddle with the controls, and overzoning leads to just as many issues as
It can lead to serious problems with refrigerant split systems. There are a lot of rules to obey when you're doing a lot of zoning with split refrigerant systems. And there is not, at the manufacturer's level, they don't have a full understanding sometimes of what all this zoning is going to do to their equipment. They think they may know, but until it's put out there and really run through its paces, they don't know the full extent. And we saw that, our firm in particular saw that in probably like circa 2016, 2017 designs where people were trying to do a lot of zoning with multi-splits. And it didn't work out so well when you had these, lightly loaded rooms triggering the outdoor unit on a call from an indoor unit. And it really generates problems at the outdoor unit level. To the point where you get odd behaviors like refrigerant venting, because the outdoor unit doesn't like what's going on its load side, on the indoor unit side. It doesn't have enough load to satisfy the engineering prerequisite at the outdoor unit side, and all kinds of strange stuff. So, for those types of systems, what we try and tell people is, look, if you're laying out a ton of money on all these German windows and ridiculous insulation levels and all this other stuff, look, your house is going to operate more as one zone, whether, you think it is, but sometimes they don't believe that. Where, Foster is, it's relevant. Like, there's a difference between me telling them as a system expert and you believing it as a system user. And if I can't convince you in the design meetings, then sometimes these things get put in and you're the science experiment, you're the guinea pig. We're gonna maintain. It's not that we don't design, we design according to the manuals and what we've got to work with. But like for these split refrigerant systems, a lot of that engineering, that's out of my hands. Like, all I can do is follow the manuals. And if it doesn't work out for you, like, there's not a lot of recourse,
Call a contractor. Yeah, exactly.
Well, even that guy, unfortunately, he's at the bottom end of the food chain. And he's just doing his best to make a client happy. Like,
yeah.
And oftentimes he doesn't have time to deal with it. He's like, I sold you what's on the truck. The manual said that this is going to work. Maybe it was at the edge. A lot of times the architects are at the edge of what's possible, right? A lot of times these guys, they come in and they want to push this thing as far as it'll go. They'll have a multi-family building and they'll tell me, oh, it's 4 stories. Hey, Jake, that refrigerant line, that line length in the manual, that's 60 feet. You put that thing down on the first floor from, 5 stories up. It's like, man, like,
yeah, good luck.
You're just asking for trouble, right? So a lot of times what we see is the architects, they'll be pushing super hard. Like Molly's saying, we're not going to give an inch. Like, you're going to pack that system. You're going to pack that thing so tight, you're not going to be able to get a wrench into it. Like, it's like, hey, unfortunately, I think sometimes, we try to push back. Some of it, we'll get to our limit. Some of it's like go along to get along, because we can only, we're at we don't want to be so hard to work with. So,
yeah.
make the friction so high that you're not going to work with us.
Well, Jake, let me ask you something about a topic that, as far as I know, is more contentious than defunding the police.
Oh yeah.
Ventilation.
Hmm?
So Foster.
So can you really just suck all your air through one straw stuck through the wall?
Well, yeah, but so I mean, there are rules. Like, okay, if you whatever balanced and this and that, and there's go to the ASHRAE manual, blah blah blah. But then, you know, there's plenty of people out there that say, no, we should be measuring CO2 to ventilate or et cetera.
Yeah.
You have thoughts on this? What are your, like, you know, professional opinion on all this?
Yeah, so like at the residential level, well, you know, if you're doing a Molly project where you got 40,000 square feet and that's a commercial building, you know, CO2 ventilation, you know, controlled ventilation could make a lot of sense for you. If you're just a run-of-the-mill residential application, then ventilating on CO, like, okay, so what you're talking about, technically speaking, is demand-controlled ventilation. If you were talking about setting a ventilation rate off a CO2 level.
Well, it's just one thought. I mean, there's just other,
one way to do it.
You know, because there's some people that say, no, you should overventilate, and others that say, no, you overventilate, you're screwing up the moisture load.
Oh, yeah.
Well, it's like this.
And energy.
Yeah, and the energy. And here again, remember, it's more important that at the end of the day you're alive than you saved yourself a penny or two. That's not a good trade, to be dead and have. So, you know, we use ASHRAE guidelines by and large. The Europeans, they tend to ventilate more than we do. So one really good commercial resource for a lot of like in-depth knowledge on ventilation is a company called Swagen, and they have this thing on YouTube called Swagen Air Academy, and they have a lot of good content by some really smart people out of the European area on ventilation rates, what ventilation rates mean for human health and comfort. Really, you know, they approach it oftentimes when they get into this stuff, they're approaching it from a commercial productivity standpoint. So they will say, or they will study higher ventilation rates to derive more productivity from their workers. And so those rates, you know, okay, so
that's fascinating, because that's really, my understanding is that we actually have a lot more to learn in that particular area, and that a lot of the studies of ventilation rates in human health they're cited like they're gospel, but a lot of them are really outdated. They're like from when we still were dying of cholera. And the buildings are different now, cities are different now, and yet where you're getting the ventilation air from and what that ventilation air is like should matter and some of the studies pay attention to that, some of them don't.
Sure. So
some of this is left over from the ASHRAE guidelines were heavily influenced by the tobacco lobby back in the 80s and 90s, where the tobacco industry wanted to set the ventilation rate higher, and they wanted one standard for smoking and non-smoking buildings, because they didn't want there to be essentially a mechanical penalty for smoking. And that they had an interest in saying, okay, ventilation is the way that we can, a perfectly acceptable way of dealing with secondhand smoke and pollutants inside. So they had a really a real interest in that, but the rate kind of, maybe the buildings now are primarily non-smoking buildings. That seems crazy to us now, but some of the logic and standards and studies from that same time are still being cited and applied.
Yeah, well, what I would tell you is this, that, you know, having lived in a home, so whether, you know, so the discussion, so let's just draw a brighter line. Let's just say, well, let's talk about ventilation or no ventilation. And what I will tell you is that having lived in a home office that's ventilated with a balanced ventilation, when I go into some of these buildings, and, you know, I might be more sensitive, you know, based on exposure to like diesel or jet aircraft exhaust and all that other crap. But I can tell you that when I go into a poorly ventilated building, within 15 minutes, I can generally tell. So, you know, if you look at this from, let's just say, for the sake of argument, our society was maintaining healthy people, healthy, productive people that could go to work day after day and get the job done, we would be ventilating. we would.
Yeah, but
we
that's
would,
not the whole situation. That's not the whole story. Like you don't just turn up the ventilation rate and then you're okay. Like there's enclosure things to deal with, and there's also where does that air come from? What like
No,
is
I
it
grant
clean
you
air?
that.
I had an indoor air quality issue at an airport once where they were sick of breathing jet fuel. Well, that wasn't because the building was under ventilated. It was because it was not controlled.
Yeah, here again, I'm not talking about a corner case. I'm not talking about living on airports. I'm not talking about living by the garbage dump. You know, if you got a special case, if you're living right by I-95 corridor, this is a different discussion, right? I'm talking about, you know, the average Joe in the average environment in the average America. I'm not talking about.
So you would you mentioned setting your recommended rates based on the ASHRAE guidelines. So ASHRAE 62.1 and 62.2 are the standards that govern recommended ventilation rates for commercial buildings and for residential buildings. And 62.2, the one for residential buildings, is not it's not been adopted by any building code except California's, although it is in some, and it's cited by some cities' energy codes, not their building code. It's in that sort of sideways. But that's pretty contentious. So there's a big debate around ASHRAE 62.2 recommended levels of ventilation being too high, and too high for health, like creating, because if you bring in too much humidity and you bring in too much outside air, then you can reasonably condition, you create bad indoor air quality. So it's not just more is better, and like if I had a choice between breathing and not breathing, I would choose to breathe. But
correct.
You also, hyperventilating isn't good either. So do you have an opinion? I'm not a mechanical systems designer. I don't know the ins and outs of this, but do you have an opinion on that raging debate?
On how much you should ventilate?
Yeah, or are these people completely out of line? Is it somewhere in the middle? Is it
Look, like I said, like this, so it depends on which segment you're approaching it from. What I've learned through my time in this particular segment is that people set benchmarks, or people set guidance and limits for different reasons. So passive house, which our architects, they like to gravitate towards that because it means no mechanical systems. That's not what passive house is for. Passive house is that marker, that 3.5 BTU hour per square foot marker, that was laid down so you could use a ventilation system to do your heating. That's why that's there. And Mr. Bean, he likes 10 BTUs an hour a square foot, because if you go 10 BTUs an hour a square foot, that means you can do all your heating with low temperature water, which is better for the planet. So you have all these, you know, ASHRAE is looking at what ASHRAE looks at, passive house, so on and so forth. You know, as a professional engineer community, we look at what ASHRAE does, you know, which 62.2 is one, 62.1 is another. You got guidance coming out of Europe that's different. So, you know, what we do is we design the systems to achieve the design point. You know, per code, per standard, we're designing to achieve a number. As the occupant, if you don't want to maintain that rate, well, that's up to you.
That's true. So, yes, I should clarify that those are design standards, not building operation standards.
And they're
capacity.
They're standards, and they're in many municipalities or many jurisdictions, the standards are not required. But the standards are standards for a reason. You know, the community has gotten together and they've said that this is, you know, a good way to go.
The thing is, though, I'm a long-time ASHRAE member, and it's crazy how some of this stuff gets decided.
I don't discount that. All I can tell you is that from, you know, from a practicing engineering, from a production engineering standpoint, it's different from okay, we're not scientists, right? At this level, what we need to do is we need to produce deliverables. I can't get bound up in a months-long argument about whether 62.2 is valid or not. Like, I have to anchor myself to some standard that people have deliberated over, because I'm not saying I'm going into this like a moron and I'm just going to do what they tell me.
No, of course.
But
You've got
what I'm
to
saying
appeal
is
to something.
From a production standpoint, I've got to anchor myself to something relevant and viable, and design the system. And then the occupant, if they're not feeling good, or they feel good at like half the ventilation rate, then
Right.
set half the ventilation rate. Like, I'm not going to tell you to do something different, but if you don't,
I don't think there's just FYI, I don't think there's currently a member of 62.2 who's a practicing mechanical engineer, by the way. Totally serious.
There you go.
Just
FYI.
FYI.
True.
That's not,
It's true.
Unfortunately, that's not unusual. And the reason, at the production engineering level, we're paid to produce. We're not paid to sit around and,
Yeah.
Exactly. So the people who are, which is, by the way, I'm an ASHRAE member myself, and I just retired, I guess, weird, as the chair of a different committee, on an ASHRAE committee. But these are wonderful people that are doing this on a volunteer basis. But you're absolutely right that it's difficult for a lot of practicing professionals to find the time and resources to just show up to this stuff. It's a consensus, but it's a consensus a lot of times of who's the consensus among is sometimes not who we think it is.
What I would tell you is this, that from all the stuff I've read, like, the Europeans are far more conservative than we are in their ventilation rates. They'll ventilate at rates far higher than we do.
Yeah. I thought some of it was lower. Like Sweden's is much lower, is it not? I mean, not that you would know every country in the world.
No, I think their recommendations tend to be higher than ours. So, you get Sturbrick banging on, passive house. Of course, they've got, they can use pretty high ventilation rates at times. And you'll get Sturbrick banging on energy this, and they'll come back with health that. And you know what? Like, you got to pick something and go with it at some point. It's not. I will tell you that at the residential level, what you're talking about is not, like, from an energy use perspective, it's not critical. Like, it is not. It would. I will tell you. Okay. What is important, right, is managing your window size and your window exposure. That's what's important.
Yeah.
Like, you guys building these giant, we'll have architects come in, we're going to build an R50 wall. Great. Well, 40% of the wall is window. So what's your average what's your average R value across that whole assembly?
I was just running.
It's half.
It can be less. It's crazy. It can be even less than that. Like, I was just running these numbers today. Actually, I'll pull some of them up because it's hilarious. It's absurd. You're
and then
totally right.
And
we have these debates over these minute things.
And you're talking about human health inside these occupancies, and so you point that window in the wrong direction. So you point it west, and now you got this massive peak cooling load. And so now your system is sized for that, and you're going to cycle that thing like crazy. And then you're not going to buy the dehumidification that you should have. And now you're going to have all kinds of problems with water dripping off ductwork and diffusers and whatnot. So, what I would tell you is, it's got to be focusing on one part of the system is not the answer. You really have to you got to understand how it all works together. And achieving chasing little point properties for the design it can be just as destructive as anything else you do, really, is what I tell you. And that's where, you need, unfortunately, a lot of residential stuff doesn't have the money to support it, but you really do need people that know what they're doing in these high performance buildings. You've got to understand what you're doing, because you're walking into a thing that's a lot higher performance. It would be like, the analog in the aviation community that I would tell you is, it would be like, designing a glider. Designing an airplane with an engine You know, that has its challenges, of course. But if you want to go find people that really know what the hell they're doing in aircraft design, you go find the people that design those gliders, because they understand aerodynamics like somebody who's designing an airplane with a giant engine does not. Like, or, you know, something like a long haul jetliner. Like, these things that are they're deceptively sophisticated. They don't seem like much, but these high performance buildings are deceptively sophisticated. You have to have a good understanding about what you're doing.
Well, even people who do that can get caught up in that, in the minutia. Yes. I mean, because you latch onto, especially I see it in the passive house community, which I love. I started in this industry in passive house, but some of the passive house people get so obsessed with you know, air sealing certain details or thermal bridging. Thermal bridging at window to wall interfaces, you know, foaming up that little space between the window and the wall, and filling it all up with foam instead of leaving a space for drainage, for example. When it's like, seriously guys, and to cite the numbers, to put some numbers on what you were saying earlier, if you have an R30 opaque wall, so a pretty good wall, but not crazy, right? But R30 is the opaque part of the wall. And you use a glass of a U value of 0.2, which is R5. And you've got 18% of that wall is glazed. The effective, which is pretty normal for most house. It's a little generous, actually.
That's low. I want 40. Like, you need 30 or 40%.
I don't know. I think my house is. My house is probably 15%. The house people grew up in is pretty low. Your house is probably, I mean, it's different if you're looking for something modern. But anyway, just to make the numbers work. So 18% glazed is like, I don't know, a craftsman house. Pick a craftsman house, roughly 15 to 18% glazed. But 18% glazed, R30 for the regular wall. The window is 0.2, U value of 0.2, which is really, really good. Well, the effective R value of the whole wall is 16, R16. You go from R30 to R6. So why are we talking about, little numbers here? You're absolutely right. That's a very good comparison.
Yeah. So,
Jake, let me. I don't want to take everybody's entire evening. So I want to ask one last question. Why are the controls for kitchen exhaust hoods so difficult? This is where,
dude.
Molly, tell me, how many hours of your life have you lost on controls for kitchen exhaust hoods?
Too many to count. Every project.
Is that right? Every project. Why is this?
Dude, I don't know, man. Like, this stuff, it continues to, let me tell you my saga about it. So I'll give you a short thing about control systems. You know, back when I was a young buck, like a couple of years ago in this business, I'm like, I'm getting into these hydronic systems. Like, why am I sitting here trying to write sequence of operations for this? Like, it's 2020, and they've been doing hydronic systems for, probably about, 1,000 years. Maybe the Romans had this stuff. Like, what the hell? Not the controls, but, and the industry is just horribly unstandardized. So everything is a different thing. They don't have standard sequences. The only standard sequences ASHRAE puts out is for VAV systems, and that was released in like 2018, 2019, I think. So when you get into these, people, the problem is people deal with their phones and they deal with their cars and they think, aha, well, buildings must be the same. And that, it's just not. It's not at all. It's all custom. So one installation be different than the next, or one guy, he likes to sell, electro air. He's got electro air in the truck. The next guy's got Stelpro. Stelpro takes a dry contact. Electro air is a wet contact. Oh, this one has a CT donut that goes on the sensing wire. This one doesn't. It's all on off. Like,
but which one is heirloom?
Yeah, which one is heirloom?
That's the one I want, Jake. I want the heirloom.
You
So
want the heirloom one?
is there no like there's no great words of advice for, you know, those of us that get stuck in these meetings? Like,
Controls are hard, and I will tell you. So here's the Europeans. They are prone. What they do is they package a lot of this stuff up. So they're systematic. They'll sell you the whole shooting match. Over here in North America, nope. Everybody's got to have a piece of the value chain.
huh.
So I mean, like on the hydronic side, for instance, what that does. For instance, I'll give you a for instance. So we're doing a historic library. We're retrofitting it, and we're cobbing on a bunch of new building to this thing, right? And we're going into the pricing exercise on this thing. A VRF system will cost me $20 a square foot. Hydronic system will cost me $30 a square foot. There's no real difference between the way those systems work. It's just that the VRF system, not everybody and his brother can take a piece out of your ass, whereas the hydronic system, everybody's got a piece of this thing. So all the way up the value chain, everybody's taking their cut. And I'm not sure, like, the hydronics industry wants to keep playing, but I keep, you know, when I run into these guys, I keep telling them, like, look, you guys, you're either going to be in luxury residential or you're going to die, like, because they're, you know, you're losing out to the VRF. I don't believe it. Like, we don't like. You guys familiar with Project Drawdown at all? You know about
never
that?
heard of it. No.
Go to that website, Project Drawdown. The number one thing you can do for the planet is manage refrigerant. That's it. Children, you know, women in schools, planting a bunch of trees, it doesn't matter. Like, the number one thing for the planet is managing that refrigerant. So hydronic systems are critical for that as well as other purposes. So we're not big believers in their refrigerant systems, but man, because they got big control over the value change, including the control side of it, their prices are hard to beat, unfortunately.
Well, it's
Not
what time
heirloom,
we
though.
get? We're 20. Yeah,
So
not yet.
the way
All
you
right.
overcome that is say, that's a throwaway system from Asia. If you want heirloom, hydronic. And sometimes people go for that.
Well, that's Henry's thing, Christy. He's a
I want my
hydronic guy.
radiant cooling now.
Oh, okay.
Yeah, I'm down with that.
Sweet,
All right.
call us up. We specialize in it.
I don't want to take everybody's entire evening. This is an hour and 20 minutes in now. I know I took the first 20 minutes figuring out how to record, but any last questions from anybody? Molly, like, anybody get that last question in? How can I possibly align the grill with the joints and the wood flooring?
Oh.
No, we're just going to align it, Foster. The answer is it's going to align. That's it.
You don't need it. It's you're switching to radiant cooling.
Yes.
No grills.
Exactly.
All
We're getting
right,
rid of those
all right.
registers.
That's right.
Get rid of that crap. Yeah.
That's right. That's right.
Although-
Heirloom.
I know.
Just remember, if you want seamless, you want it to all disappear. And, you know, Foster, I sent you in the email. The classical architecture, okay, is better suited to the stuff we're talking about because it's got some rules. The modern architecture it does not typically obey the rules. So pointing
Because
windows.
classical architecture is based on hundreds of years of how you build things and how you should put them together and why you don't have 40% glazing on a wall.
And those people, you know what you had to do when you had to make heat? Those people had to go down the basement, shovel coal in the furnace, or they had to pay somebody.
Their people did. They had people.
Their people did.
Yes.
But you know what I'm saying? Like, it was harder. Oh, so I got a question for you guys. You guys know what wingback chairs were invented for? Okay, go ahead.
I guess
No,
not.
I don't know why.
Was
So
it to
wingback-
change your? Does it have to do with the mean radiant temperature?
Nope.
Oh,
The
dang it! Come on.
That was close.
Just
So
say
the
yes anyway.
The wingback chair was invented for rooms with fireplaces and they pointed the chair towards the fireplace, and the wings deflected the rush of air, cold rush of air from the windows and the leaky walls around the occupant and
That's
into
so
the fire.
smart.
Yeah, crazy,
Wow.
huh?
Where the heck do you get
That's
a
a
piece of
great
knowledge
piece of
like
trivia.
that? Yeah, where do you, you just make that up, or like, you know, you're like me, you think about shit and make it up, or or is this actually
No,
like?
I was reading about, it was how to retrofit, like Sweden published this, the government, I think, the Historical Society of the government published a manual about how to update Swedish buildings with ventilation. And I believe it was in there somewhere.
Huh. I'm going to pull
Yeah.
that one out at a
Yeah,
cocktail
that's a
party one day.
useful piece of knowledge.
Yeah. Yep.
Cool. Well, thank you.
Got it.
All right, Jake, thank you. That was great. And I really appreciate your time. Molly, thank you again for participating and keeping us out of the ditches. Christy, great commentary, questions as usual. Thank you very much. So
Thanks, guys.
once again, this is for the ICAA. I have no idea what they do with it once I send it on to them, but eventually someday it'll be on their website. I suppose.
They're playing it. Somebody texted me today. Actually,
Really?
Peter Marciano texted me today saying that he had this podcast recommended to him by someone who didn't know that he knew us. So apparently it's out there somewhere.
There you go.
Yeah, it's really happening. It's really happening.
All right. That's fantastic. I mean, I enjoy it just without the internet part of it, so it's okay for me.
Me too. I learned so much. Thanks so much, Jake, in particular this week. But these are so wonderful. I really.
All right. Well, thanks for putting up. Thanks for putting up with an engineer.
No, it was on purpose. Believe me.
All right.
And
sweet.
So, anyway,
Good.
thank you, everybody.
Have a good
night.
night.
Have a good
Good
night.
night.
Bye-bye.